thank you. So as a member of the marketing team, I get to see lots of news and announcements come in every week of amazing things that have come to pass, and products and services and solutions that are all based on Risc-V. It's really amazing to see. So what we thought we'd do with this 45 minutes is bring together some really interesting companies and members from around the world, different geographies who are doing amazing things with Risc-V, and they're going to each introduce their products and services to you and show them what they're all about. So I'd like to start off by introducing Bilal from 10x Engineers.
A wise man once said to me, Bilal, never stand between people and their food, or they will eat you. So as the last panel, or the last session before the lunch on the last day, I apologize. But I'll try to make these 10 minutes, not the most boring 10 minutes for you at this summit, by talking about how we have tried to combine services with open source contribution to enable innovation in Risc-V. Hi, I'm Bilal, co-founder of 10x Engineers. First, an introduction of 10x Engineers. So we're a services company, which means that we don't have products of our own. We help our customers build their products. We help them build products in two areas: camera ISPs, specifically for computer vision, and Risc-V. We have a team of about 80 engineers, and we started about 3.5 years ago. So really excited to be here in Europe for the first time. So most of our customers come to us with problems. And those are their problems of today. In the last 3 days, we have seen that the evolution of Risc-V is at a stage where we're really trying to build high-quality, really performant Risc-V IPs. So what is the problem that our customers are bringing to us? Well, design verification is one, compliance with Risc-V specification. Those of you who are familiar with verification, this is your typical writing UVM test benches, writing tests, closing coverage, and all of that. We help our clients do that so that they can get to market really quickly with really high-quality products. The second area where we help them with is RTL design. So this is them building their IP. It could be within the core or on-core blocks, and we help them do that design and implementation, whether it's for FPGAs or ASICs. And finally, compilers and tool chains. No project is complete unless you can generate software for it. So we help our clients on the compiler side, specifically on LLVM, and increasingly we're seeing MLIR as one of the compiler flows that our customers are asking for. So very early on in our journey, we asked and we committed ourselves that we're not going to be just takers from this open source community. We are going to contribute back. This is back when we were like a 10, 15-person organization. And we decided that we're going to commit our time and resources to contributing back to these open source projects. That was a decision that was made very early and has become part of our DNA. The effort started as some random tasks that we pick up, but thanks to help from partners in open source, Risc-V International, Jeff, and in the open hardware community, Flo, Jean-Roch, thanks to those efforts, these projects matured, and our contributions also started to mature. Our team started to learn. Today, Umar from our team is one of the maintainers of the architecture test repositories. Fatima, sitting right here, she's one of the maintainers of the open hardware repositories, working on CVS6. And Ali, he maintains our repositories for Cloud 5. I'll talk more about that. And that's what Calista talked about, our 10x Engineers being a lab partner. Ali leads that front for us. Now, each one of these are our 3 anchors. They help other team members contribute into their respective projects. Other team members come in, pick up a task, deliver it, and move on. But these 3 steer that effort and stay connected with that community. So that's where our open source contributions are today. Now, we asked ourselves this question, and it was partly inspired by our contribution to the open source. What are tomorrow's problems of our customers that we can try to help them solve? And the answer was obvious. Software, software, software. That's when we started working on a cloud-based platform that enables software developers to build their software on Risc-V. That's what we call Cloud 5. You can learn more about it at cloud5.co, but it's a cloud-based continuous integration and sandboxing environment for Risc-V application development. The basic software stack, your language compilers, your build tools, your foundational libraries are pre-installed, so you don't have to worry about cherry-picking the right commit. You can be on your way to development very quickly. Once you've compiled, you can run these applications on emulated QEMU instances or real Risc-V development boards, the High 5 and the Vision 1 and 2. And that list keeps growing as we go along. The platform is free to open source communities. So anybody here that's a contributor, maintainer to an open source community and wants to port your application to Risc-V, please log on to cloud5.co and let's do this together. We can even help you port the software if that's what you need. The tools that are available today, if you're interested in details, it's an ever-growing list, so you can always go and look at the latest, and this is not complete. But like I mentioned, it's your language compilers, it's your build tools, and tool chains. Some runtimes as well. So, open invitation to all developers. It's not perfect. It's an evolution. It's in its first phase. But if you want to contribute it, if you want to build on top of it, please join. I was really happy to see Rise present here, Larry spoke, and then the Vitamin V team that's doing a great work in trying to port the cloud stack to Risc-V. And then we're hoping that we'll sort of build on these efforts and essentially accelerate software development on Risc-V. So that's what we're doing. But before I leave you, I have one more thing to say. So if you think back to the time that you were first introduced to and got excited about Risc-V, it wasn't just because the specification was open source. It was also because high-quality open source implementations were available for you to just download and run. Whether it was the Rocket or the Boom from Chris's team in Berkeley, or the Swerve family, of course, from Western Digital, or Florian's Ariane, for the first time, it felt like microarchitecture was accessible. That it wasn't just a thing that you read in a textbook with block diagrams. It was something you could hold in your hands and tinker with, maybe even improve. So to me, the future of Risc-V, yes, it's open standard, a global standard, but it's also high-quality, open-source IP that's freely available. That ushers in a new era of innovations. That allows developers, that allows the next generation of developers to build products that we can't even think about today in this room, using those building blocks that we're building today. Frankly, that's what got me interested and excited after 10 years in the industry. And I hope that was the same for you as well, for many of you with white hair at least. So where are we now? Going forward, I know I speak as an outsider, but I think Europe has to lead in this. We have to fund, we have to develop, and we have to maintain high-quality IP so that startups tomorrow can use it. And not just because of European sovereignty, but also so that little kid inside each one of us is excited and hopeful. And for the next generation of Roger Espazas and Krista Isanovich to be inspired to build on our shoulders. Well, thank you very much for your time and attention.
Thank you very much. Thank you. That's great. Thank you. Okay, that was amazing. Great. Thank you for your talk. I'd next like to invite up Florian Zaruba from Axelera AI.
Thank you very much. This was really a great talk. and I know what you mean with this excitement. I'm personally an engineer at heart, and I'm still in an engineering role, so don't expect a lot of marketing. There will be a bit of marketing, but my main goal is to make you appetite about what we do, about the company. I'll give you a bit of a rundown what we've been up to, and then a sneak peek, not too much on the slides, but be sure to catch up with me to actually talk what our plans are within Risc-V. First of all, what is the market of Axelera? So is it another AI company? We have learned a lot of AI. I think there was not a single presentation without AI, probably. This one will contain AI as well. So Axelera is focusing on the edge devices market. This is a market that I personally also didn't know too much, still don't know it too much, but it's a big market. If you consider all the connected things that talk to each other, it's over 40 billion devices. And if you look at the traffic that's actually being sent back and forth, it's mostly all about video frames or images, which essentially is the same thing. So instead of sending all around this data, what the industry has settled on about is processing more and more on the device itself. But AI needs a lot of computational resources. We all have heard about it. And existing solutions we saw didn't fit the market needs. So Axelera is focusing on these edge markets and trying to outperform both in performance as well as in price and in usability, because this is a big factor, especially if you compete against things like CUDA from NVIDIA. And we see the market right now is still highly fragmented, so we do see a big market opportunity. How do those markets actually look like? So there's a whole set of different opportunities. I just want to pick out a couple of those I like. Retail, for example, think about cashierless checkout systems. You have your cameras and you want to see what the people actually put in the product basket. You have drones. Computer vision is very much needed on there. And then finally, industry, quality assurance, etc. This is all being done on a camera stream on device. And so what all these markets need is a powerful and a cost-effective hardware and software solution, and actually a platform that can do all this computer vision. Axelera itself started in 2021. I'm personally one of the co-founders, so with great pleasure, it pleases me that it grew that much, with that many people. We are over 150 people right now, roughly 50 PhD, and I like to joke that despite having 50 PhDs, we made it until today. We're doing compiler, VLSI design, software, and the entire hardware stack, as you will see. Our headquarters is in Eindhoven, but we are a truly European company. We are allocated in Zurich. I'm personally in Switzerland. There's a big office in Eindhoven, the headquarters is in Bristol, but we do have a lot of remote people as well. So if you have an appetite for remote work, Axelera is a good place for you. We started with a first funding round, taped out our IMC technology, which I will touch upon in the next slide, and then onboarded more and more employees until this today, where we are shipping first early access products of our Metis system, and we are working on the next generation. So Axelera's technology builds basically on 3 pillars. The core value of Axelera is this in-memory compute technology. This is something that has been incorporated from IMEC, IBM. You see all this, the IBM chip, the big one, people from IMEC. And the in-memory compute array is basically a large SRAM where you can store your weights and you can stream in your vector, and then you do a vector matrix multiplication inside the in-memory compute array. And why this is beneficial, we'll also touch upon in the next slide. Complementary technology pillar number 2 is the machine learning and quantization framework. The computational accuracy that we do is int8 on this IMC array, so there's a need that you quantize your neural network so that it can efficiently exploit the in-memory compute technology. This is why it is complementary. And we have a large machine learning team that actually works on quantizing already trained neural networks existing customer networks and pipelines to make use of the in-memory compute array. And then finally, why we are here today, Risc-V is an enabling technology for us that allows us to program and make this in-memory compute array actually accessible and usable for many, many applications. At the core of the application, which is really fundamental to me, is the software. The usability is key. So we have this Voyager SDK, where a customer can describe its pipeline in a very low-code format. And this will automatically quantize and map the network to the in-memory compute array. It will generate a data flow graph that is being mapped to Risc-V instructions that in turn controls the in-memory compute array. And this gives us really the edge over the competition in terms of efficiency, throughput, and cost. If we zoom in, said I'm a technical guy, so there is definitely an architecture rundown. If you zoom in into what we have built in terms of hardware, you see that the core of the project is this digital in-memory compute array with a relatively large storage of 4 megabytes of L1, a VEC portion that can accelerate your linear functions, and an auxiliary unit that takes care of all the kind of outlying instructions. The Risc-V core is dedicated to controlling all those units. We replicated this 4 times to form the 4 AI cores. We call one of those units AI core. And then there's a final 5th Risc-V core that is doing system orchestration tasks. And finally, a root of trust, because protecting tomorrow's models is key. And finally, this 32 megabytes of L2, PCI Express, because we are connecting to these host systems. We've taped out Metis. You can see the chip here. I'll not run through the different performance factors, but basically, really good performance, exceptional power efficiency, usability is really at heart, and in general, providing really a good value. We package up those chips into different product lines. On the left, we have the M2 card. Because we are so efficient, we can actually exploit the M2 form factor and can live with the energy and power envelope that M2 is providing. But we can also scale up for more performance. For example, the PCI Express card or the 4X Metis platform. Then we partner up with existing hardware vendors because we want to go into this edge market. And those people then take our accelerator card and put them in their products and sell it further. Summing it up, the unit gives you the operations per second that you need for tomorrow's and today's networks. And in turn, this comes at a really low cost factor, because if you compare it to incumbent products like NVIDIA cards, you can save, for example, up to $800 for the same performance that you get. If you compare it to even more high-performance products from NVIDIA, for example, you save even more, and you can still achieve that with just one Metis chip. In total, this can save you between 2.5 to 3 million in capital expense, just if you think about 1K units selling. So if you're in the embedded markets, which I doubt here, please reach out. And there's also to me, and there's a couple of other Axelera peoples, and we'll get you in touch with the salespeople. What's really important and what I want to leave on the table before I leave the stage is our CEO always says the best is yet to come. And I think this is really true. So we are expanding further our Risc-V footprint. We have really nice ideas and actually stuff running for the next generation of our product. And we are planning even more great stuff for the generation after that. If that kind of piques your interest, you want to work, we are hiring in all sorts of pillars. Compilers is certainly a big one. Firmware, operating systems, so we do have a strong software focus. But there's also, me personally being from the R&D, we're also looking for further R&D strength. The focus will be on vision applications, so we know our market and we want to go into that market, but we're also looking to go into more high-end edge and potentially HPC markets. If that piqued your interest, come join me, come join us. Be sure to catch us on this last day of the summit, and I hope I could pique your interest. Thank you.
Thank you, Florian. So next, I'd like to invite up Liang from DeepComputing. You probably have seen some of his amazing products on the developer zone. He's been very kind in giving us those to show this week. So yeah, thank you.
Last year in North American Summit, we announced our products alone, but today we're going to announce more things with our partners on the stage. So, and today we focus about how do we work with a partner to roll out and hardware device mass produce. So I'm Liang, he's a founder of DeepComputing. So what do we do in DeepComputing? We are product solution pioneers. So basically, we're trying to prove and improve Risc-V. For example, anyone you guys have SoC, we can help you to prove that your SoC can do things like laptops, tablets, and any more. And the most important thing is that we prove that your products, your SoC can go into the mass-produced products. It's possible. So what experience we have? We have a one-stop integrated solution with all the partners from all the way from SMT, doing the schematic, and to layout and factories and assembly, even packaging, design, everything. We do everything in the fast speed. And the most important thing, we work with the partners that doesn't really put the priority of making money, but believe and hope, believe, or they are all Risc-V believer. One day we're going to take 1/3 of the world. So the most important thing, because Risc-V just like startup, is a chicken and egg problems. So there's no scale, expensive, and everything. We had to do it very different way, very different from ARM. So when we make product, we start with the very complex product, and then we use the SoC approach. One SoC can branch out a lot of products. Later on, we'll show you. And then we can achieve 12 weeks. To achieve, you can see on the booth, we can achieve hundreds of working DVT samples. And just like the laptop we have now, we show you we are on a Risc-V laptops doing the presentations. So what we do, 2024, we have 2 platforms. One is the Starfire 7110. One is from SpaceMid. So you can see SpaceMid here. So, and we roll out the 8-core laptops. And then we have an AI speaker. So anyone interested in your SoC to making AI and talk to the open AI, come and find us. And then we roll out a development pad and trying to 8-core development, trying to meet the price one below 200 euros. So, and we have a very stylish mobile geo contents. We partner with like Wolf SSL and Express VPNs. So the most important thing with the developer, we make a workstation to do more coding and help improve. And I think the last one is the modulars. So I will talk about later. So let's see, come back to the old days. This is the old Roma. So, and it's still very stylish. It's still very stylish. So we're still working with the partners to get the most exciting Ubuntu to running on it. We're working very hard, and as well as the Fedora. So all come into the old device and with the LTS. So now, and we launch a very good, very stylish packaging instead of the very big chunk. Now it's very stylish. So it's our 8-core. It's an 8-core AI-capable SoC. So they do a lot of innovations and matrix multiply on their vector engine. So they support I think probably in this, the whole year is the only one support RVV 1.1 with 256 length. And those most important things that we pick all the chips can run on 2G frequencies. So with 8-core. It's pretty powerful compared to the first generations. So what do we do with hardware if there's no software? So we partner with a lot of distribution damping, as we know. And then we straight away, the SOC guys help us to build a bond with the 23rd port 10. And now we work with, later on with Canonical to make sure we support 2404 LTS. So a lot of work. Now we have a laptop right here, hopefully it's not broken. And I let Ethan to play around it and talk about the experience. Ethan, over to you.
Great, thank you. Can you hear me? Okay.
No,
Excellent.
that doesn't work. Push the button. I help you to push the button.
This one?
Yeah.
All right. Excellent. So very quickly, my name is Nathan Egge. I'm the co-chair of the TSC and RISE, and I gave a talk yesterday about some of the priorities in RISE. So one of the things that we talked about is that, software developer priorities are one of the things we focus on. Really what developers are asking for is they're asking for access to representative hardware. It's the number one issue we hear about, and it's for good reason, right? If you're doing open source enablement, like you said, you can use emulators for correctness, but it's really insufficient to land patches, right? And I gave an example of this in my talk yesterday. What's really neat about the laptop form factor is it actually allows you to test more applications under more environments, right? So now you can play around with web browsing, gaming, image editing, video decoding, things like that. They work today, but they're really missing optimization. And what you get with a laptop is you get hands-on experience, and you get to dog food the programs, right? You get to understand what works and what doesn't work. So one of the things people think about when they think about software is that it's written by folks in a cube, with a terminal off to some server software somewhere. But really, open source software is written in a community. So these are pictures that were taken this week with the laptop. Got early access to one. In the middle, you can see some folks at the RISE Lounge. That's Ludovic and Kieran, and we're tinkering with some Risc-V algorithms to see how they work. On the left, I got Doom running on it the other night just to see if that would work. And then on the right, I'm enjoying the Roma 2 at the Hofbrauhaus, right? So this is really allowing people to kind of play with Risc-V technology where they do open source development. All right.
Okay, back to me. Thank you, Ethan. You think about it. The laptop this year definitely enough power to do some software works. And thank you, Nathan. So one other thing is that how we do completely different from ARM. Right, back in when I was in Nokia, we have 9 ARM chips on our feature phones. They're all integrated. Then they're very integrated version. Now, I try this completely different. Me involved with a very special partner to make sure that Risc-V can scalable because Risc-V speed is very fast. So what is that? So we roll out our first motherboard for a modular Risc-V motherboard for framework laptops. So the reason why we're doing it, why modularity matters. Risc-V is in a spiral that chicken and egg, expensive, no scale. Low scale, expensive. So how we break this cycle? Why modularity matters? So Risc-V very fast speed. So last year is 4-core, 20 nanometer. This year going to 6-core, 8-core, and 16-core. And even some of them rolling out 32-core, all into 12 nanometer, and then 7 nanometer, and even 4 nanometer is coming. It's very fast. What can we do? It's very fast. So we want a machine. I don't want to do a laptop. Keep doing the thing is irrelevant to Risc-V. So we just do the board. You can see the photos. You can just change the motherboard. So you can change the 4-core. This year you can change it to 6-core, and 8-core, and 12-core, anything you like. So it's very modular. In terms of development, I don't need to write screen driver again. I don't need to deal with another mode again. You can see from Roma first and Roma second, all the mode changes. The structural things changes. So and you save a lot of time. So we make this motherboard took us only 10 weeks. It's walkable, you guys can see it. And we are getting into DVT and straight away out to 100 and thousands volumes. So, and more importantly, Risc-V in the stage is still in developer communities. We need a lot of guys to help us develop the software, as a previous speaker says that. So it can modulate, replace. It can expand. You can see you have a lot of expansions. You can expand your DDR, expand your NVMe, expand anything you like, as long as you're on framework. So, and it runs most of the Linux distros. And that's why we work with a lot of communities. So, and because of that, then we have very good friends, in our circles. You guys can see our social medias. So we have a Risc-V communities, not here, but be patient. We have frameworks community with millions of fans and users. We have Ubuntu, another millions. And Fedora, you can name it. So enlarge the user base. So now let's take a look what our great partner from Framework CEO's videos and see what he talk about.
Philosophical alignment between Risc-V and Framework. Both are really centered around this idea that ecosystems are more powerful than the sum of their components. When the team at DeepComputing reached out about building a Risc-V mainboard for Framework laptop, we were just so excited. We can't wait to help enable developers, tinkerers, and hobbyists and help extend on the breadth and depth of the Risc-V ecosystem. We're really looking forward to getting this mainboard into all of your hands.
You can see what Risc-V is still buggy, right? So make sure we have the know. Be patient with us. We are better. This is very fast. This is the first Chrome version with a hardware accelerations. So that's why we need to roll out the more hardware to Google guys to help us to improve. So we back to the last big chunk. We let our important partners, because this year is a very special year. I hand it over to Gordan, our key partners.
All right, it's working now. Sorry for that, everyone. Hey, my name is Gordan, and I'm representing Canonical. We are celebrating actually 20 years of Ubuntu this year. And from desktop to all open source everywhere on every single ISA, that's really our motto going forward, right? But we started really modestly on the desktop in 2004. I hope that a lot of you remember the first CDs that you received and how excited you were about entering the Linux world in the most accessible way possible. But since then, we really grew towards becoming the #1 operating system in all the hyperscalers, as well as the #1 Linux for certain private cloud deployments. We also built Ubuntu Pro that kind of augmented our open source portfolio of support and security services that we're doing. And once again, getting back to that point on every single ISA, why we are here today is really to showcase our commitment to Risc-V. In 2004, we launched that first Ubuntu desktop. And right now, in 2024, together with DeepComputing, we have Ubuntu 2024 really soon on the Roma laptop too. And I think this is a huge milestone, right? Because as Ubuntu started really modestly on the developer desktops, we captured the mind share of young innovators and tinkerers out there. And similar to what Nathan did, a lot of smart people are playing around, improving, breaking things, and continuously using software, right? And I think really that the platforms that DeepComputing is building, they are really going to change how people perceive Risc-V. It's becoming more and more real. People can really do things that they haven't been able to do so far. And that's why we really want to make sure that the whole ecosystem shows their appreciation to DeepComputing and the partner ecosystem. And that's why we are leaning in, really investing in this area. And once again, to echo what Nathan said, basically, the job of all of us here, of the whole Risc-V community, is really collaboration, but it's also making sure that we celebrate moments like this, where devices like this can be seeded all around and capture the mind share of young innovators, developers, and people who will later on contribute to the open source software ecosystem that we will all benefit from. So we might not see these gains immediately today, but you'll be very thankful if you go on LinkedIn and repost everything that Yuning is sharing about his products, about it being available with all the other Linux distributions, and Ubuntu being one of them as the premier partner. So once again, thanks a lot, Yuning, for inviting us here.
Thank you, Gordan. Thank you for your help. You know, we've been running just two months, then we got 2404 to running on our product, and then we continue working on it. This year is a very special year. I'm wearing a lot of hat. I like these T-shirts. It's 20 years. So it's 2024. We hopefully Risc-V doesn't take that long, that 20 years. So I thank you for you guys. Thank you.
Thank you very much. We'd really like to thank DeepComputing for all the help that they've given us with the developer zone. Please, if you want to interact with the new laptop, it's right over at the back corner. Yeah, come and have a look. It's really great. So next, I'd like to invite up Philipp Tomsich from VRULL.
All right, so this is actually the partnership announcements of a good friend and a special guest, Andy. Can you join me here on stage? So Andy May of Stream Computing, he asked me to lead through this today, though. Given the fact that he's a little bit jet-lagged, so I'll walk through there and pass it over to him. So Stream Computing is somebody I've known for a couple of years. They're a Chinese semiconductor company that is in the machine learning AI space. And given that the theme of the event has been AI more than Risc-V, this is a very fitting announcement. So the amazing thing about them is that they have been having very high performance matrix silicon for 3 years now, 4 years? 4 years, so I'll just hold that one up here. So this is the actual chip with a date of 2021 on it, a manufacturing date. And the silicon improvement validated chipset is actually going up against NVIDIA and has been going up against NVIDIA for a couple of years. So Andy, can you just give a bit more background? So I know you, but I haven't been there when it all started.
I can give you a brief introduction about stream computing. Actually, we have been working on AI chip for over 5 years. Today, everybody is talking about like matrix extension for Risc-V, but actually, our first generation chip with what Philipp showed to you guys has been shipped out to our customers. I mean, over like 10,000 pieces to this year. We quite understand. I mean, we have a lot of experience in like what customer needs and what the advantages, disadvantages, how to do the trade-off between the software and the hardware. In the past, we had very good cooperation with VRULL, with Philipp's team. I think it's time to strengthen our cooperation. And I really looking for, I mean, through our strategic cooperation, we can create very competitive, I mean, better products for our customer across, different regions, different market. And I'm really looking forward to the cooperation. So Philipp, hurry up and let's open bid.
So I'll walk you through the two announcements that they have in more detail because we're involved in both of them. So we've been working with Stream Computing for the last year or a bit longer to set up a way to build a European AI solutions company to go into the same market as NVIDIA. So European strategic digital autonomy is a big topic, been a big topic in most of my engagements over the last year and a half. And as part of that, VRULL, together with our sister and partner company, Software Ecosystem Solutions, has founded semiconductor startup in Europe, Vibium, so it's in the early stages. It actually had a bit of whiplash going from client over to AI first and then bringing it back into the client and industrial markets. So Vibium is really and has been aimed at following through on the goals and the promises of European digital strategic autonomy based around Risc-V and based around the realization that we will need software together with hardware, basically integrated solutions, reference designs. So you've heard it all over the last couple of days. And what happened about a year ago was the release of ChatGPT, and suddenly everybody has been focused on AI and realizing the value of it. So with that shift, we also shifted and redefined the strategy in the early stages, and our partners at Stream Computing were the ones that we turned to license their MPU IP. So basically, their matrix unit, their accelerator unit, in order to start the other way around, not with the general purpose solution and then adding AI, but by starting with the AI side. Now, that is only one half of the relationship that we're disclosing today. The second part is, and that has been in the works for a while as well, is a cooperation between VRULL and Software Ecosystem Solutions with Andy's company. So they have a great software stack, but it is not the software stack that European or Western companies expect. So this is something we know very well, something we have been working with for many customers. So VRULL is, for example, helping to upstream and maintain the T-head custom instruction support, and has been very successfully doing so over the last 2 years. And we're working with Stream Computing on exactly the same, bringing the software stacks that we in the West expect to their solutions. And this benefits both of these endeavors. So first of all, they can share the load of the software and of the software maintenance on a much wider basis, because there's LLVM in there, there's MLIR in there, there's all the usual frameworks. But if they do it alone, it's different from having a wider user base. And of course, this helps our own endeavor with bringing this to European designed silicon by having a shared software base and sharing that open source foundation for the software instead of having to do it twice. So, as I said, AI has changed the priorities. AI has changed the picture. And AI has also changed the way we need to look at this European digital strategic autonomy that everybody is talking about. So a year ago, it was servers. Now it is the AI accelerators, and then having AI and AI solutions seep into all markets. Axelera is doing a great job on targeting the edge, on targeting automotive. But at the same time, we have the HPC market, we have the enterprise market, and we have uniquely European challenges like the need for privacy, the interest of companies to guard the privacy of their customers and wanting to do computation and inference in their own data centers. Now, we believe that what we're doing together is extremely important for Europe. So Andy has built a solution 3 years ago, 4 years ago with his company that addresses the Chinese market and their particular need and shape of solutions. We're adding what Europe is missing. We're adding higher bandwidth memory, we're adding FP8, FP4, and also support for sparsity in order to align this to what we need and what we expect. But all of that based on a common software ecosystem, and that common software ecosystem will be built in Europe now under this collaboration, where we are going to do more work for Stream Computing and do more software work for Stream Computing in order to leverage the last 3-4 years of development, but building a new future, a new European future around AI based on Stream Computing IP. So thank you. And thank you, Andy, for doing this with us.
Thank you. I'd like to thank everybody, all our presenters this morning. Hope you enjoyed seeing some of the newest developments, the solutions and products based on Risc-V. I'm in the marketing department. If you've got any interesting stuff that you want to send us, we have our blogs, our social channels, our news site. We are really keen to amplify anything that you've got going on and the new stuff that happens over the next year in Risc-V. So yeah, please contact me if you have any information, any stories that you'd like us to bring out. So thank you to all the panelists, all the presenters there, and thank you.